All right. Good morning, everyone. Welcome to our May 13th Istio working meeting. We've got a pretty short agenda today, so if you've joined us with a particular thing to talk about, there's still time to add your topic to the agenda as we begin. And we will start with this zone-aware routing proposal. Open the RFC. Get this tab shared. Is someone with us who can speak to this?
Yeah, I'm here.
Okay, Sebastian, why don't you take it away?
Yeah, thanks. So this has been proposed previously in issues, but there hasn't been any formal proposal, and I'd like to do that. So we got an in our company we had like a custom service mesh, and we're migrating to Istio. We have a huge deployment, thousands and thousands of VMs, and we do use zone-aware routing currently. And one of the issues we're having with Istio is as we migrate towards Istio, we don't have that, and we are seeing huge increase in costs in zone-aware. Zone traffic crossing zones. Like the best way to solve that is zone-aware routing. It basically is, yes, Steven.
Oh, sorry. Do we not have this with like destination rule?
Yeah, I was going to talk about.
Okay, sorry.
Yeah, so destination rule or Istio currently has like weighted load balancing. Like you can do locality weights and say I want X% of traffic from my AZ, from one AZ to go to another one, but it's very manual, right? So you have to explicitly say which percentages you want to go to each zone, right? That is not ideal, at least in our case, because our environment is very dynamic. You can have services which are running on a subset of the zones and other services that are running on other subsets, depending on which clusters they're running, on the capacity or available to those services. We also use very big spot fleets deployment. So according to the availability or the cost of the spots, you might have more pods running on one zone than another, and that is very dynamic, right? It changes all the time. So using like manually defined percentages is really not a good, not good for our case. I also referenced there like Envoy Gateway. Envoy Gateway currently supports this and is actually the default implementation when using the traffic distribution prefer same zone on Kubernetes, right? So just to know that Istio wouldn't be the only one to support this kind of feature. So the main idea I wanted to propose is there could be like two implementations, but mainly adding a field to destination rule to allow configuring zone-aware routing that would be exclusive with the current weighted locality, but it could work with failover and failover priority we already have, because zone-aware routing only works on the highest priority, that is priority 0, and failovers still work and do not perform any automatic affinity. So that's one thing, and the other thing is so the thing how this works is you have to tell Envoy on the bootstrap configuration which cluster it is part of, right? And this unfortunately has to be like a statically defined cluster also in the bootstrap. Usually people just create a local cluster fixed, and then it is type EDS, and then Envoy fetches the endpoints for that cluster, and that way it knows the cluster the proxy is part of and how many instances it has in which zones and whatnot, right? And then you configure the other clusters with zone-aware routing. So Envoy now knows all the instances that form part of its own cluster and all the other instances on the other clusters, and it knows what amount of traffic to send to each one to maintain like an average load equivalent amongst all zones, but trying to remain as local as possible, right? So this is tricky because we have to add this cluster to the Bootstrap configuration. And there's a comment from Keith that was saying if we could add all the clusters a proxy is part of, because Istio currently supports a proxy being part of multiple services. Well, the thing is, we can't, because Envoy only supports one cluster, but we remain with two options. Or either we populate that cluster with the endpoints from all the services one proxy is part of, or only the first one. So it's something we would have to decide as well. And I think that's mainly what I had to say. So there's a few knobs on this. I think the only one really useful for Istio would be the min cluster size. That would be how many pods or instances a cluster can have and do zone-aware writing, right? Because sometimes if you have very few pods, you don't want to perform zone-aware routing because there's no way to be to perform like what would you say, like distribute traffic accordingly if you have very few pods. So that's something to consider, and it's like the only tweakable value. The other one is the fail traffic and panic, but I don't think that's very useful for Istio because we actually disable panic threshold on Envoy entirely, so that's not really relevant.
So you want something that's a bit more configurable than just setting preferred close on the service?
Sorry, can you repeat that?
Yeah, I'm just wondering why like setting preferred close on the service isn't good enough.
But preferred close on the service is forcing all the traffic from one zone to the same zone, right?
So it's too strong.
It's too strong. So yeah, you can have a service that is only running on one zone, and it will overwhelm the instances in that zone of another service that's probably running on multiple, right? And so we're running regional clusters with and the pods of services could end up in any zone. So that's why also you can have like not equal distributions, right? And the same zone currently also relies on failover. So if the instances on your same zone are unavailable, you failover to others, right?
Yeah.
Sebastian, have you looked at trying EWMA?
Nope. But why do you think that will work?
So EWMA distributes load based on latency.
Yeah.
And so in the default scenario, assume all your services respond with equivalent latency, but are geographically distributed. EWMA will prefer local ones under load conditions.
Yeah, I understand. I mean, it could work, but I think it's like more of a hack. I mean, you are relying on the fact that probably cross-zone traffic has higher latency than local zone, but that's not necessarily the case sometimes. And also, you're going to perform like locality after the fact, you know the latency, right? Not before. And you also
so there's a couple
are
things.
probably going to open connections and send traffic to all the endpoints until you know the latency, and then reduce the traffic, right?
Right, but that happens very quickly, right? Like the latency adjustment is proportional to the number of endpoints and the number of requests that they see. So yes, like if you had 10 endpoints, it might take 10 requests for EWMA just begin to adjust. But remember that you said, right, you have this requirement that I don't want to overload a zone, right? And so let's say I have one endpoint in the same zone as the client, 10 endpoints in a remote zone. EWMA will do a much better job with load distribution if the local zone begins to become overloaded, right? So as a general rule, EWMA is a much closer fit to what you're actually asking for than like a statically configured locality-aware load balancer.
Yeah, I think
In like much more generally, in fact, I would say EWMA is a much better average choice for most people than locality-aware load balancing.
yeah, I'm not. I think it could work, but I think it depends on many different things. So if you have services that are not sending like very constant traffic, then AWMA may probably not work as correctly as this. Also, and it's not something that
Well, actually, I would disagree with
me,
that too.
but
Right? In steady state conditions, right, non-loaded states,
yeah,
EWMA will adjust to approximate the locality-aware load balancing reasonably well, and you can test this.
yeah, I'm sure we can test this, but I mean, there's something that is also not trivial, that with zone-aware routing, you're actually like reducing the number of endpoints in the cluster effectively for the proxy. So you're generating less connections, keeping less connections open, because you don't have you don't have to send traffic to those endpoints. With AWMA, you do have to open the connections and know the latency to know if you want to send traffic to it or not. So I understand what you're saying. I think it could work, but I don't think in our case it's something we want. Or maybe the combination of the two.
Well, so like, yes, you're correct that EWMA will eventually generate connections to all endpoints. Are you actually under connection saturation conditions?
Sorry? If we're under connection saturations? No, but we do have huge services with a lot of endpoints, and reducing the amount of endpoints that get sent traffic is actually very useful in our case as well.
Okay, like we have discussed before, allowing EWMA to function with endpoint sampling, right? It's not a feature that we've built where we don't deliver all endpoints, but just a subset of them for a service, because there are just too many, right? And so just sampling them effectively randomly solves that problem while still yielding a good load distribution in combination with EWMA. We haven't built that feature, but it's not a particularly complicated feature. You just need a stable hash to do the sampling. Right, and you would have to be talking about like situations where you're talking about hundreds or thousands of endpoints in a particular service.
Yep, we have that.
Okay, so but in many respects, I would almost be more interested in implementing that feature than any improvements to zone-aware load balancing. Like zone-aware load balancing, like even if like we still distribute all the endpoints, we just categorize them, right? We just don't create connections until we create failover buckets. But the state distribution requirements are the same. In fact, they're worse because we have to send all the zone markings.
But we currently do that. So that's not something we had to add. In fact, there's very little we would have to modify. Like we wouldn't have to set weights over the zones. We can send them only with the same weight, and that would be it. And having the local cluster being populated, that's like the only modifications being needed.
Sorry, I must have missed the earlier part. You said you're doing some form of subsetting?
No, we don't do subsetting, but Envoy does the subset itself, right?
Yeah, it doesn't reduce the load on the control plane to distribute all the endpoints, which is the primary load I would be concerned about.
It does, yeah, depending on what you want to do. I mean, if you were to like calculate the percentages automatically on the control plane, that would be like a huge cost, and zone aware routing would avoid that. But currently, I mean, it wouldn't nor add nor take any load from the control plane.
Yeah, I'm just pointing out that zone aware load balancing requires us to put zonal markers onto the endpoint metadata.
It's already on there. I mean, we don't have to.
No, yes, I know. I'm saying that if we used EWMA, we could remove it.
Yeah, I don't think we would, because we do stuff with that, I think, and it's also like, yeah, the localities have the zone metadata. I mean, and we use them for our current weighted load balancers. So I don't think we would ever remove them, right?
If EWMA consistently outperformed it in all cases, we might actually suggest that.
Okay, but if people want to like do failovers to or I don't know, route percentages of traffic to other regions or stuff like that, like it would probably.
Yeah, then you would explicitly opt into it, right? Yeah, I understand how we would evolve the control plane, but we may make our default recommendation EWMA instead of zone aware. Right, if in average and edge cases it outperforms zone aware, right, or approximated it and outperformed it in the edge cases, then I think we would probably prefer it because it's simpler.
I understand. I don't think AWML fits our case, and currently there's no way to configure zone aware routing on Istio.
I'm going to push back. Have you tested EWMA? Right. You say it doesn't fit your case, but it might actually be better than what you're currently suggesting.
Yeah. Well, I can take and see if we can test this, but yeah, I don't think it's better or equivalent to what we have. Yeah, I don't know if any other ones have questions or want to chime in on something. So I think, Luis, you're trying to put like AWL as a silver bullet for everything. I don't think that's going to be the case. And it also replaces other load balancers, so that's probably not fit for everyone as well.
So any load balancer whose job it is to prefer to send traffic to a certain set of endpoints, but then in situations where latency begins to degrade in the preferred set of endpoints, to then redistribute that traffic, right, is either going to require a lot of configuration, right, as in zone aware, the various zone aware load balancing mechanisms within Envoy, or it's going to look like EWMA, effectively.
Mm-hmm.
We don't actually have, and this is probably a shortcoming in Istio, we haven't done an analysis of this, and we probably should, because it would probably allow us to answer these questions much more concretely for people. If the variance between the performance of EWMA and locality-aware load balancing for the same use case was very small under steady state and edge state conditions, you would definitely prefer EWMA. One, for algorithmic complexity reasons and maintenance reasons, but also for reliability reasons. Right? We have seen use cases and edge cases where zone-aware load balancing causes pathological behavior. Right? It overloads zones. It doesn't degrade. It naturally degrades.
I mean, we run zone-aware routing on our huge deployment, and we haven't seen any pathological behavior.
So I have 1,000 endpoints in the remote zone and 1 endpoint in the local zone, and I misconfigure, or I statically configure weights, and I massively overload the local zone and degrade my SLA.
Yeah. I mean, that's correct, but that's the current state where you have to manually.
Yeah, no. But I'm saying that's a bad state for users to end up in by default.
Yeah, I know. That's why I also propose. I mean, if Envoy Gateway also does like default to zone-aware routing for preferred same zone, we could also do the same.
Yeah, and generally speaking, like we have
about
switching the default to EWMA and not to locality aware.
Yeah, I
It's
understand.
difficult.
I would like also others to chime in. I mean, as I told, like Kubernetes with topology aware routing on services basically does the same as well.
Mm-hmm. Yeah, it maintains a hierarchy, and roughly performs the same function.
Tells you which endpoints should receive traffic from which zones, right?
So I understand, like, Istio already supports Kubernetes topology aware routing. We also are adding support, it looks like, for EWMA. What I'm unclear about is what in this proposal is different from the topology aware routing that we support today.
And currently, the routing currently is static. Like either you route all the traffic to your same zone, or you failover and you route to all zones, doing a failover, or you use the locality weights, the manually defined locality weights, which are percentages, and you route statically defined percentages, right? So if the topology of your service varies in time because you have suddenly more endpoints on one zone than another, then your percentages could be off, and also your other services could not have the same distribution, and you could overload one zone, right?
Yeah, it's not very adaptive, like Sebastian's right.
Okay, so this would add more nuance to that algorithm by stating that if there's a minimum, if we don't meet the minimum size within a local zone, we will include some number of remote endpoints up to that size in our primary cluster. Is that right?
Yeah, so what you would do if the minimum is not met, then you would route traffic to all the zones in the same region. And but if the minimum is met, then you would attempt to route as much traffic as possible to your same zone, depending on how many instances your own service has in that zone and on the other zones, right?
Yeah, and is your objective here primarily minimizing latency, or are you worried about interzone egress fees?
Mostly interzone egress fees. We currently have thousands of dollars and thousands, yeah.
Okay, so in a scenario where EWMA finds, potentially you're going to have remote traffic that is lower latency than local traffic, just because all sorts of strange things happen on the network. In those cases, you would prefer to stay local nevertheless because of the pricing.
Yeah.
Well, it definitely seems like this could be worth a test. I would be interested in seeing like a test that runs with the zone-aware routing load balancer and shows total zonal egress, and then run the same scenario with EWMA. And let's have a look at the total zonal egress under that circumstance as well.
Yeah, I could see if I could set up some testing and provide the results.
Yeah, that would be very interesting. Thanks.
Yeah, Mitch, on the testing side, we should probably honestly set up some simulation of this. It wouldn't be that hard. We don't actually need the endpoints to be in different zones, right? We just need to simulate their latencies and pretend what zones they're in.
And our own telemetry will tell us about cross-zone
exactly.
egress.
Exactly. So it wouldn't be that hard a test to set up.
Yeah. Also, Luis, sorry, but you're also, like I said, you're also relying on the fact that cross-zone traffic for AWMA, right? Cross-zone traffic should be slower than local traffic, but that is not really the case in some cases. Like in AWS, a single zone has multiple data centers, and you could have the same latency going from one of those data centers to another one, and then from going to the same zone. It really depends on a lot. And
I think it is generally true. Like I've seen the inter and intrazone latency stats for all the major clouds. It is generally true. You're right. Like the differences can be very small. So I agree. Like
but if the difference is in the like less than a millisecond,
yes, it could be in the noise with relative to the performance of the backend.
Exactly.
Oh, that is true.
So in those cases, the EWML would really provide like no value for us, right?
In that case, yes, is if you're actually crossing zones as opposed to just data centers within the same zone.
And so in that case, when you look at like using topology-aware routing today, you're in the what do we call it? The fatal case. You're staying within the same zone, so you're fitting within your pricing characteristics, or like you're meeting your financial objective there. However, that like traffic effectively can slow down exponentially, infinitely, as long as the service stays available. Did I get that right?
Sorry, you mean currently?
Yeah.
Yeah. So currently we do that. So we maintain affinity of the zones, and if one zone degrades, that zone degrades, right? Yeah.
And you can't just use outlier detection to evict those local underperforming endpoints?
Yeah, you could, and sometimes, I mean, also has check-in picks it up. I mean, yeah, you could do that. That's why, I mean, it's not something we are worried about. I mean, because Envoy has other mechanisms for detecting unhealthy hosts or degraded hosts, right? I understand that AWMA would be like a single package that would probably cover lots of use cases. But
no, I think the subsetting argument is reasonable, right? Like, so, like essentially today, right, load balancing is an algorithmic component and a subsetting component, generally speaking. Today, the subsetting component is we don't subset at all, right? Or you use the subset API or you create another service.
Mm-hmm.
Envoy offers a feature to let you kind of create a subset based on proximity selection.
Yep.
Which is a perfectly reasonable feature. So you could say, look, I want to select, I'm only going to load balance among the 10 nearest endpoints, right? And then the actual load balancing you do might be EWMA within that set of 10, right?
Yeah.
And then you periodically reassess if an endpoint gets ejected, I need to refill the subset, and so I'll rerun the selection, right? That's totally normal kinds of things, and there are lots of different types of subsetting algorithms.
Yeah, I mean, you could use, like you said, like right. So you could use zone-hour routing with AWMA, or you could not use zone-hour routing and have like AWMA across all zones of your region.
And they would achieve subtly different effects.
Yeah.
Which for a lot of use cases might not be meaningfully different. But for some would be. Mm-hmm. And we need to be able to tell people, like actually the subsetting I'm fine with, right? That part makes sense to me. Right, we're telling Envoy, don't send traffic to more than 10 endpoints, right? That's my availability requirement. I wish they didn't call it load balancing or routing. I wish they called it subsetting, but that's different.
Okay, so you would be okay with going on with this proposal?
I'll take a look at the doc in more detail offline. If the feature is essentially pick the first 10 most local endpoints and load balance between them, I don't have an inherent like functional objection to that.
Yep, that's basically the case, I think.
Would I recommend people use it by default? I think this is probably, again, we need some research on this topic.
Yeah, I think a bit of research would be nice. But I mean, as the reference serve a purpose, so like other people are doing the same. But I mean, you could default to this and probably would have like the same effects for most people, and unless they want like to maintain locality always, because this only maintains locality if you have like the same distribution or very close one. Yeah, I don't know. It would change behavior, right? Like default into this.
Yeah, no, this is not the same thing as strict locality waterfall load balancing, right? Where I pick the closest endpoint, and if there isn't, right, and then I pick the next closest one. But like the load balancing algorithm is always pick the closest one, right? Which tends to hotspot traffic.
Yeah. So I mean, that's probably useful. I mean, I know in GKE people do like zonal clusters, but I don't know like in the wild how many people do that. How many people have like regional clusters and have like capacity to distribute it automatically across all zones, right? So I would think if people are using mostly regional clusters, AWS only supports that. Like you would probably want more zone-aware routing than the current like single zone, right?
It's debatable depending on people's. I think it's perfectly reasonable to say this is my maximum availability subset, and size that based on their knowledge of the service size. I don't know if we could default it, right? So let's say a service only has 3 endpoints in a regional cluster, 2 end up in one zone, 1 end up in another. We would almost always tell people, well, don't set your subsetting selection to select anything less than all the endpoints, right? That would be a bad idea. Right, just because pod disruption or node disruption could easily drop the SLA of your service. If you had 1,000 endpoints, yeah, pick 10, right? Depending on how much traffic you think you're going to get and how they handle it, picking 10 is totally fine.
Yeah, but yeah, so defaulting would be like we have to research and discuss if we would want to default this. I would say no for now, and then we can see.
Yeah, it just adds a lot of complexity for people if we don't have good defaults. But I understand the argument on both sides. So we would need some research on that.
Yeah.
Like generally speaking, based on what I've seen elsewhere, for services that have thousands of endpoints, generally distributing some log of the number of endpoints randomly selected to each of the clients yields a reasonable load distribution and a reasonable client latency profile. But under a certain threshold, there's no point in doing that.
Yep.
And that is if those systems are stateless. If they're stateful, then you can't do that at all.
Yep.
Okay, so it sounds like we've got some research that we agree on that needs to be kind of done in terms of viability, but some productive conversation here.
Yep. Thanks for the feedback.
Yeah, thanks for bringing this, Sebastian. Look forward to seeing the research. I'm going to switch back to our agenda. The only other item on the agenda is a release update from Peter.
Yeah, thank you, Mitch. Just quick update. We were planning to release tomorrow and everything was on plan, but there's a under embargo Envoy vulnerability that we're discussing right now in a security group, and maybe we will delay 1.30 release for a couple of days waiting for Envoy fix. So just for everyone's information.
That's great to know. Thanks.
Okay, thank you.
All right. Well, if no one else has any updates, we can all have 20 minutes back. Thanks, everyone, for joining.
Thanks. Bye-bye.